Hi, I'm Dan Cortopassi. Welcome to a new show I'm calling DCC Shop. In this episode, I'm going to be installing a Locomotive 5 DCC sound decoder, speaker, and new lighting into this HO scale Athearn SD70ACe model. Unlike my model building series, where I focus on a complete build of a model, including paint, details, and DCC, this show is going to be mostly about DCC installations. I'm going to try to keep the external work on the model to a minimum. I have a number of models like this Athearn Genesis SD70ACe that are pretty accurate right out of the box. They don't need major cosmetic work, they just need DCC and sound. This Athearn Genesis HO scale SD70ACe is DCC ready, meaning that it currently runs on DC but is ready to convert to DCC operation. This model is from an older production run back when Athearn was still using bulbs instead of LEDs for lighting. Right now it's in factory new condition. The only change I've made so far is to replace the original plastic couplers with Cadys. I want to install DCC and sound in this unit and improve the lighting. Before starting a DCC install, it's a good idea to figure out what you want to accomplish besides just putting in a decoder. For this unit, I want to remove the factory bulbs and replace them with LEDs. Specifically on this engine, that means the front headlights, rear headlights, and ditch lights. I also want to add ground lights, which is a cool feature that some new models have installed at the factory. I'm not going to try to light the number boards on this model. I'll also need to install a speaker. Before doing anything else, it's a good idea to test the model to make sure it's running as it should. This model has been stored for several years without running at all, and sometimes lubricants can become congealed. I've hooked up a DC power pack to my test track. It looks like it's running pretty well. It's stalled a couple times, but that could just be dirty wheels. I don't see any major issues that need fixing. To remove the shell, first I need to remove the couplers and draft gear boxes. These models have 2 additional screws tucked away above the trucks, one near each end of the fuel tank. I'll also remove these. I'll save the screws, couplers, and other parts in a small container so I don't lose them. Now I can separate the shell from the frame. The first thing I see is that this model already has a spot for a speaker. Athearn has offered these models with SoundTrack sound pre-installed, and they seem to be using the same frame for the non-sound models. That'll simplify things a little. I like to use factory speaker locations when they're available since it saves work. The other thing to look at is the existing light board. There are actually several ways to go with this model. It has both an 8-pin plug and a JST connector, so a decoder using either of those could be installed that way. If you wanted to keep the factory bulbs, then all you'd need to do would be to remove the dummy plug and the JST connector and plug in the new decoder. You don't need the dummy plug for DCC, so it needs to be removed for either a JST or 8-pin decoder. The third option is to use a board-style decoder to replace the entire light board. This is my preference. It's slightly more work and requires a little soldering, but I think it ends up being neater and there isn't so much unnecessary circuitry taking up space in the model. You could also do a purely wired install with a different style of decoder, or use one of the third-party adapter boards that are available. This is the board-style decoder I'll be using for this model. It's an ESU Locomotive 5 DCC Direct. This one has built-in capacitors that will keep the model running for a few seconds if it loses contact with the track. This will help prevent stalling in areas with dirty track or unpowered turnout frogs. It also has 8 function outputs for lighting. I'm not going to keep the bulbs, so I'll start by removing those. I'll disconnect the clips that hold the bulb wires in contact with the light board. Now the chassis is completely separate from the body. I'll also disconnect the clips that hold the leads from the trucks that take power from the wheels to the light board. Before I remove the motor leads, note that the light board labels them orange and gray, even though the wires aren't those colors. The DCC standard has a color code to make it easier to tell which wires are for what purpose. Instead of orange and gray, Athearn used red and black, where red stands in for orange and black stands in for gray. It's important to make a note of that, otherwise the model's normal direction of travel could end up reversed. Now I can remove the light board by gently moving the clips on top of the motor that hold it in place. If you're an experienced installer, you could save time by just pulling the entire light board with the lights still attached. I'm doing it this way to hopefully make it easier for beginners to follow. Now the chassis is stripped of everything we don't need. If you're lucky, the rear bulbs will just pull out of the shell. Athearn's SD70ACe has a removable roof, which makes it easier to get to the headlights. These should also just pull out. Sometimes the bulbs have an adhesive on them, but thankfully mine don't seem to. The ditch lights are a little trickier. One of the things I don't like about the Athearn ditch light bulbs is that they're inserted from the bottom and point up. That means most of the light is being wasted shining on the inside of the ditch light housing. I'll start by carefully prying them out. The wires are wound through a couple of loops inside the body, so they need to be untangled. Once they're loose inside, they can be pulled out. If you want to save the bulbs, do this step gently. Otherwise, just yank them and throw them away or recycle them. Now the body is free of the bulbs and all the associated wire. Before doing any wiring, I want to physically install the decoder and speaker. The decoder has slots that fit over the clips on top of the motor. I had to finagle it a bit to get the rear slot to engage. The capacitor near the slot is close enough to push on the plastic clip. The decoder should be oriented so that the long row of contacts is on the fireman side. I looked at my stash of DCC components and found this 28mm 8-ohm speaker. The instruction sheet that came with the decoder states that the speaker impedance should be from 4 to 16 ohms, so this speaker should work fine. Besides having the right diameter, I chose this speaker because it has a thin profile. There's not a lot of clearance between the speaker mount and the side of the shell, so a deep speaker won't work in this location. I'll be using some RTV silicone as both an adhesive and sealant to secure the speaker. I'm using a bent paper clip as an applicator. After wiping off the excess, I'll put the speaker into the speaker mount. The sealant will ensure that the frame functions as a speaker enclosure. With the decoder and speaker in place, I can start wiring. The instructions that come with the decoder have a larger than actual size drawing that's really important to refer to when wiring this decoder since there are so many solder pads. I'll start with the motor connections. I like to tin the solder pads and wires first, then I'll make the connections. The red wire goes to the motor plus solder pad and the black wire goes to motor minus. After the motor, I connected the leads from the trucks. I removed some of the tape from the frame that was holding the wires down so that I could trace them. It's important that the wires don't get crossed, as that could create a short on your DCC track. ESU sells 36 gauge insulated wire for DCC installations. I'm going to use brown to wire the speaker. In order to keep splices to a minimum, I'm going to remove the short wires that came with the speaker. I'll use new pieces of brown wire to connect the speaker directly to the decoder. Since there's only one speaker, polarity doesn't really matter. If you were doing a multiple speaker install, it's important to pay attention to the polarity to keep the speakers in phase with each other. At this point, we should be able to test the locomotive. I usually buy my ESU decoders blank, though they're sometimes sold with sounds preloaded. Since I have a Loc programmer, I went to the ESU website and selected an appropriate sound file for an SD70ACe. It's usually safer to test the locomotive on a programming track first before risking the decoder on a live DCC track. Most of the time, if there are issues, the decoder won't program properly. If that happens, you'll know there's probably a short or something wrong with the wiring. I'll do some quick rudimentary programming first, just setting the decoder's address to 9395, the number of the locomotive. Sometimes the Loc programmer will change the project type the first time you try to program a decoder. This is normal. After it does that, I'll save the file. To make it easier to find later, I'm calling it HO BNSF 9395. Then I'll use the programmer's driver's cab function to test the model. It runs back and forth. When I press the horn key, F2, I get a simple beep, which is part of whatever sounds are preloaded into the decoder at the factory. Now I know that the decoder install is basically working. I can run the locomotive and the speaker is connected. I'll load the sound set next. With the Hi-Fi LocSound 5 sound sets, this can take up to an hour or so. After the sounds are loaded, it doesn't look any different, but when I test the model, I hear the prime mover startup sequence, and the horn is way better. There are a number of horn sounds to choose from. I'll leave mine at the default setting for now. I'll worry about tweaking things later, but for now the basic DCC installation is done. I prefer warm white LEDs for most of my locomotive lighting. I'll be using two types of LEDs for this model, 3mm warm white LEDs and 603 surface mount LEDs. If you want to see how I prepare LEDs, please check out Model Building HO SP Consist Part 8 LED Primer 101 here on the channel. The only difference for this model is that I won't need resistors since the LocSound decoder I'm using has built-in resistors. To make headlight lenses, I like to use fiber optics. Fiber optic strands need to be supported on the ends to keep them aimed properly. For this locomotive, I'm going to use 1/16 outside diameter aluminum tubing. I'll use a 1/16 drill bit to bevel the ends of each piece of tubing to make it resemble a reflector. Then I'll cut the tubing to length with my razor saw. I've made a support block out of a piece of 80,000 styrene with the edges beveled for the rear headlight. After removing some tape that helped to hold in the old bulbs, I'll glue this in with liquid styrene cement. When the glue is dry, I'll use a 1/16 drill bit to clean out the headlight openings and drill through the support block. The reflector end of the tubing should be recessed a little into the headlight casting. This will allow room for a lens. The front headlight tubing fits tight enough that I don't need adhesive. Since there's more room, I've cut the tubing in the rear a little longer. I'll secure it with CA. The headlight castings are now ready for fiber optics. I make lenses on the ends of the 30 thousandths fiber optic strands by exposing the end to a heat source. A lighter works well, though you could also use a soldering iron. It can take some trial and error. My goal is to make pairs of lenses that are about the same size. The lens should be shaped like a football in cross-section. Lately, it's become more difficult to find fiber optics that'll do this properly. This is some old stock material that I've had on hand. Some of the newer stuff just makes little blobs instead of lenses. Since this material has become hard to come by, I've taken to cutting the strands as short as possible. This pair is for the rear headlight. This longer set is for the front headlight, since these will need to go through the cab. I'll insert the fiber optic strand through the tubing I installed in the rear headlight casting. Once both are in, I'll tie them together with some heat shrink tubing. I'm not actually going to heat it, since that could damage the fiber optics. A little canopy glue applied from the inside will secure the strands. The lenses fit into the castings just right, and with the aluminum behind them, they look fairly convincing even when off. I'll do the front the same way, routing the fiber optics along the same path as the original headlight bulb wires. I had to use 2 pieces of tubing since I couldn't quite fit both strands and the tubing through the opening in the rear bulkhead. It's important to check the fit of the roof. Sometimes the fiber optics can push the roof up slightly, making a gap above the windshield area. This looks good. I'll take the roof off again for now. Last, I'm going to paint the visible parts of the strands inside the cab black to prevent any light leaks. I'll install the LEDs for the headlights a little later. Right now I'm going to switch and work on the ditch lights. I could just put LEDs into the ditch light housings as is, but I like to do it a little differently. With a little luck, pulling straight up on the ditch light casting should remove it without damaging the locator pin on the bottom. I'll use a paper clip with a slight bend in one end as a tool to push out the factory ditch light lens. Once the lens is out, I can clean up the hole with a 1/16 drill bit. Just like the headlights, I'll make some aluminum tubing reflectors. These just need to be really short to fit into the ditch light housings. LEDs are pretty bright, so to help keep the ditch light housings from glowing, I'll paint the insides black. I'm using 603 surface mount LEDs for the ditch lights. I soldered my own, but you can also get them with the leads already attached. I'll use a dab of canopy glue to tack glue the LEDs into the ditch light housing. I do this with the light attached to my test battery so that I can make sure to aim it so that the brightest part of the light is shining through the hole in the aluminum tubing. The canopy glue should allow the LEDs to be removed later, just in case they ever burn out. I was able to reinstall the ditch lights using the factory mounting pins. They were pretty secure, so I didn't need an adhesive. I carefully routed the wires along the path used by the factory bulb wires. I'll be using 603 LEDs for the ground lights as well. On the model, there are detail parts that show where the lights should go. I'm after a subtle glow. I don't really want to see the LEDs. Luckily on this model, there's some empty space inside between the sill and the bottom of the cab floor. I'll use a 1/16 drill bit to make a hole behind the ground light detail part castings on each side. I made a simple mount using some scrap styrene with a hole drilled in it for the wires. I used some CA to secure the LED to the styrene. I'll add a second piece as a spacer. The LED is sandwiched between the two. I'll glue these together with liquid styrene cement. I've glued the LED mount I made inside the shell, lining up the holes so that the LED shines down through the bottom of the sill. This is looking pretty good. Since I haven't been able to find that many colors of solderable magnet wire, by my own convention I use green for the positive and red for negative on my 603 LEDs. I've tied the green wires from the ditch lights and ground lights together and spliced them to a piece of blue wire. This will eventually be tied into the common positive connection on the decoder. I've connected the blue wires from the 3mm LEDs that I'll be using for the front and rear headlights to the blue wire from the ditch lights and the ground lights. A single piece of blue wire will go down to the decoder. I've put some larger heat shrink tubing around the 3mm LEDs. This will fit over the smaller tubing around the fiber optics and keep the light aligned. It also shields the LEDs so that light doesn't leak out inside the locomotive body. Now I need to connect all the individual light wires to the decoder. I'll start with the front and rear headlight wires. For the other lights, I've spliced some 36 gauge insulated wire onto the magnet wire. I used green and purple for the ditch lights. I'm not sure if BNSF had flashing ditch lights on this particular locomotive, but in case they did, each ditch light needs to be on its own lighting output. Keeping them separate will make the decision to have them flash alternately or not a matter of programming. If they're both on the same output, then both lights will always be on or off at the same time, and no programming can fix that. The ground lights, on the other hand, should operate together, so I've spliced both leads onto a single tan wire. DCC color coding does not have enough colors to standardize decoders with a ton of lighting outputs, but it's still a good idea to use different colors to keep yourself from mixing things up. Neatness counts, as it can be difficult to get a locomotive back together with wires hanging everywhere. Loose wires can also sometimes hang down and scrape on the flywheels or other drivetrain parts, making noise and potentially causing other problems. To help with that, I've made a couple wire retainers from bits of styrene. These need to be located in areas where they won't interfere with the chassis. Fortunately, this particular locomotive has a decent amount of space in the upper part of the shell, so it's not too crowded. I've also used some short lengths of heat shrink tubing to group the ditch light and ground light wires into a cable. I've connected the ditch lights to aux1 and aux2 since those are set up for ditch lights by default. The ground lights are connected to aux3. Since the decoder board seems to like to pop off the rear clip, I've added some Kapton tape there to hold it. I've also put some tape on the rear truck wires to replace the factory tape that I removed earlier. And that's it. The wiring is now complete. It's a really good idea to test everything before putting the engine back together. I've put the engine on a test track that's hooked up to my loc programmer. First, I'll go to the software and change the behavior of the light on aux3 from a beacon to a plain light. I'll also turn down the brightness since ground lights don't need to be super bright. I can do more programming later, but this should be good enough for testing. Time to try it out. Once again, I'm using the driver's cab feature in the loc programmer software. The front headlight works. The rear works too. The ditch lights come on and flash when the horn blows. As I mentioned earlier, I'm not sure if this is the correct behavior for this particular engine, but it can be changed with programming later. The ground lights also work. I'll probably want to do more programming on this locomotive in the future, but now I know that all of the lights I installed are working. Now for the moment of truth. Since there are wires and electronic parts in there that aren't from the factory, sometimes reassembly can get a bit tricky. I always check to make sure no wires are getting sandwiched between the shell and the mechanism. The shell should seat back down on the frame as it did before disassembly. If it doesn't, don't force it. Chances are there's some wire or something else in the way. This one seems good. Once the model is back together, I like to run it with the sound off. I'm listening carefully for any noises that might indicate wires scraping on part of the mechanism. I don't hear anything, so this is good. I noticed that there's a small light leak under the engineer's side ditch light. I'm going to see if I can fix that. Since the ditch lights aren't glued down, I've pulled that one up slightly. I'll use a hobby knife to apply a small amount of black RTV silicone. After pressing the light back down again, it looks like the leak is sealed. The last thing is to make some lenses for the ditch lights. These are exactly the same as the lenses that I made for the headlights, except that the stems are much shorter. I'll glue them into the castings with a small dab of canopy glue. The canopy glue will dry clear and be invisible. I'm pretty happy with the way the lights turned out. The headlights and ditch lights are brighter, and the fiber optic strands focus the light in the direction of travel. The ground lights look pretty good too. It runs well and sounds good to me. This engine still needs some programming. I need to adjust the sound volumes and speed match it to my other models, but I can do those things later. I'm going to call it done for now. So that's about it for this SD70ACe for now. I have more models like this one that are basically already finished except for the DCC installation, so I'll be doing more episodes of the show in the future. If you like the program, please like and subscribe. Stay tuned and thanks for watching.